Hello, everyone. I'm here today to talk about taking control of the drone threat, specifically in the most sensitive and challenging environments. And I'll do that in the context of presenting some findings and implications from a very interesting survey that we conducted together with IDGA, a survey specifically of counter UAS professionals in the field. My name is Jeffrey Starr. I'm the Chief Marketing Officer of D-Fend Solutions, and I'm thrilled to be back at another IDGA Counter UAS 2021 Summit. These are always great events, fantastic specialized audience of highly qualified professionals that actually participated in the research that we conducted and that we'll be sharing today during this session. Here are my contact details. If you want to continue the dialogue and discussion about this study with me after the session, you can email me and you can also connect with me on LinkedIn. Just a few words about the company, D-Fend Solutions. We're a leading global provider specifically of RF cyber takeover counter-drone solutions for the most sensitive and challenging environments. We have a global presence. We have hundreds of deployments worldwide. A lot of the point of view that you'll hear presented during the session comes from our real-world experience of these deployments. We have over 100 people in 5 offices all around the world. We've been selected, proven, tested by the most demanding security agencies in federal law enforcement and homeland security, as well as a number of other use cases and sectors. And we've also been deployed at the largest scale events in the world to protect these events with tens of thousands of attendees. I always like to start with the latest incidents. This is the drone threat that we've all seen across multiple use cases, multiple sectors, multiple environments. In the upper left, this was actually quite commonplace in the baseball season this year. There were a number of MLB games disrupted by drone incidents that actually stopped the game and caused major havoc in the middle of a game. On the lower left, you have another use case, which is smuggling. And smuggling, of course, by drones can be across borders or into prisons, smuggling of contraband and other disruptions to borders and facilities. In the upper right, aviation and airports, drone usage by airports and the incidents arising out of that. Careless usage continues to be a major factor and a major issue, major use case that's driving a lot of the demand for better, more effective counter-drone solutions. And in the lower right, of course, military and defense, drones, commercial drones, off-the-shelf drones being used by non-state actors to wage asymmetric warfare against conventional armies and special forces. So these are some of the environments, some of the sectors, some of the use cases. Now, specifically as it relates to this study, as I mentioned earlier, we wanted to focus on the counter-drone professional. We wanted to focus on those with the experience in the CUAS world. So there was a very simple but very important entry ticket into this study. We asked, are you involved in your organization's counter-drone operations or system selection? We only wanted those who were directly involved. You had to say yes. If you said yes, that got you into the study. So this study was conducted strictly amongst an audience of counter-drone CUAS professionals, highly qualified in the area. But we wanted it to be cross-sector. So we asked, what kind of organization do you work for? And here we were actually quite pleased. And this gives you a representation of the cross-section of sectors that involved themselves in this study. So it's about 40% special forces and military, 23% national security, homeland security, almost 20% law enforcement. So those kind of 3 use cases and sectors dominated the participants in this survey, but you can also see a good representation of a few other sectors as well, including VIP and executive protection, landmarks and government buildings, local government, arenas, stadiums, prisons, and more. Now, all of this points to that cross-section of the wide range of environments that are now looking at or currently deploying counter-drone solutions. So here you see some visual representation of a number of the sectors that typically have been the early adopters in this space: military, law enforcement, aviation, national homeland security, maritime borders, and VIP protection. However, we see this spreading into a number of other sectors as well, including prisons, media, enterprise, landmarks, stadiums, local government in the safe city context. So there's a wide range of environments now looking at counter-drone solutions. Now this continues to increase. It continues to be a major source of concern. We asked a question specifically, even in the slowdown year of COVID, how many drone incidents or intrusions did your organization have to contend with in the past year? And it was quite striking. You can see here that the numbers, these are not onesies and twosies. These are happening at quite a steady clip. You can see more than 10, 31%, 6 to 10, 11%. So most organizations are dealing with these on at least a monthly basis, if not a weekly basis. It's not something that happens a few times a year. It's something that's very, very frequent. Now, more importantly, what were the consequences? How did this affect your organization, or how does it affect your security agency? And interestingly enough, the number one thing that came up by far was operational disruption. Now, all of these other consequences, certainly property damage, reputational harm, injury, all of those are very grave concerns as well, and you always have to prepare for the worst case scenario. But the fact that operational disruption was so high means that that's something that wasn't necessarily getting the attention it deserved. Everyone was kind of focused on some of these other issues as well, but operational disruption was by far the number one consequence of the drone incidents. And how does that compare with past years? How did 2020, I should say, compare with past years? Again, major increase, 63% reported an increase in incidents, and only 6% reported a decrease. So again, we see this rapid growth in the problem itself as it relates to number of incidents. And it's just nonstop. You've all seen the headlines and you've all been contending with this issue. All kinds of incidents in the news all the time, whether it be presidential planes, drug cartels smuggling, contraband using drones, disruption of sports, as we saw in the video, airports and aviation, of course, continue to have to deal with this issue. So there's a wide range of incidents that continue to be in the news every day. Now, what's interesting about all of this is all of those incidents that you saw in those videos presented earlier were done with common off-the-shelf available drones that can be purchased on Amazon or purchased at any retailer, or do-it-yourself drones from conventional off-the-shelf commercial parts, drones that cost less than $1,500. So all of these incidents were caused by easy to purchase and build drones that can be accessed from the retail very quickly. Now, we wanted to get, first of all, a sense of the scope of the problem from the users. How much are these a threat? How much of this is a threat? And of course, it was overwhelming, no surprise there. 78% of the professionals strongly agreed that rogue drones entering their facility or their operation have become a major threat, a major problem, a major source of contention that they have to deal with. Now, which of the following types of outcomes is your organization concerned about? So we saw earlier that the biggest concern in terms of what actually happened with the consequences was operational disruption. But on a go-forward basis, where are the concerns? And again, you see operational disruption as the number one concern, but of course, a number of others are also rising in the degree of concern in terms of what organizations are worried about and how they'll have to contend with. So, for example, human injury and death, property damage, communication disruption, transportation disruption. So multiple types of disruption in addition to operational disruption continue to be a source of concern as it relates to rogue drone incidents. Now, what are some of the factors? And this is where we saw organizations getting much more sophisticated about how they analyze the drone threat. They're actually now segmenting this and looking at the different drone types, the different drone models, and what type of threat they can present to the organization. And assessing that, you see three big factors. When they look at the drone threat, the commercial drone threat, they spoke specifically on, do these drones have the ability to fly long distances and or ability to carry a heavy payload? That, in addition to their increased ruggedization and durability, ability to withstand difficult environments, weather, and so forth, these are kind of some of the major threats that organizations are looking at when they assess specific drones and how it relates to their environment. And that kind of points to the need that organizations are realizing that when they deploy counter-drone solutions, they have to look at a wide range of threats. They have to look at those most dangerous drones, those drones that can carry a heavy payload and travel long distances, but also the do-it-yourself drones that may share those same characteristics, in addition to the Wi-Fi drones that in some cases are more used by the hobbyist or don't have those capabilities, but could pose other sorts of risk as well. But there's an increasing sophistication in terms of focusing on the most dangerous threats and the most dangerous drones as it relates to payload and distance capabilities. And therefore, we see a kind of differentiation in counter-drone capabilities and a need to focus on deploying capabilities that focus on the most dangerous threat. And those are specifically, as it relates to quantifying some of those characteristics I mentioned earlier: heavier payloads, payloads of 3 to 12 kilograms, longer distances of 40 to 20 kilometers. And those drones, of course, the most advanced, sophisticated, modern, recently released protocols on the market. And this is where we see the threat coming from the more sophisticated actors, those involved in terror and crime and intelligence gathering. At the same time, there is the factor of the less critical threat, but still threat of some reckless or careless users with the smaller drones as well. So, but there is a greater sophistication now on not chasing every single drone that comes on the market, but really focusing on the most dangerous drones that carry the payload and that travel long distances and that represent the most serious threat. And these kind of exist at the cusp of these three factors. We mentioned the distance and the payload, but also the accessibility, really focusing the counter-drone efforts on those drones that are not only the most dangerous, but the most easily accessible by potential hostile or careless actors. Now, we also asked, how is the organization prepared for these drone incidents? What sort of preparation has been conducted? And here, we were actually gratified to see more planning, more analysis, more sophisticated assessment than has occurred in the past. Well over half of the organizations mentioned that they're doing very systematic, thorough risk assessment, including mapping out the different types of drones and how to respond to the different types of drone threats. Another 28% had not quite gotten there. They're doing more general threats plans as it relates to counter drone in general, but they're not yet really making that next level of sophisticated analysis in terms of differentiating between different types of drone threats. Another 16% need to get with the program, really haven't prepared for this emerging threat. Now, the other aspect of this is relating these different drone types to the different drone threats and making that really sophisticated connection between what are your threats, what are the issues that may confront your enterprise, your security agency, your sector, your use case, and then mapping them to the different drone types. So as whether it be attack, collision, smuggling, they typically come from the higher capability drones that we listed earlier, versus espionage, harassment, and nuisance may represent a different type of drone profile or drone threat. You saw there a little bit of contrast between different methodologies, different technologies as it relates to the drone threat. And this was some of the most interesting or remarkable findings that came out of the survey. We asked about some of the conventional or some of the typical technologies that came out of the conventional battlefield environment, if you will, and how are they applicable to the new urban, the new sensitive environments. And it was quite remarkable, some of the answers we got. So for example, as it relates to jamming, we said, is the potential of jamming to disrupt internal or nearby communication systems problematic enough to actually avoid adoption of such a system? And the findings were quite remarkable. Over half either strongly agreed or somewhat agreed that jamming-based technology is not in and of itself suitable or sufficient for their use case. Less than half felt otherwise. So there's an interesting kind of trend going on in realizing that some of the conventional technologies used before to deal with UAS threats may not be applicable or not sufficient in today's urban or otherwise sensitive environments. Also, we asked the same thing about kinetic, and here it's obvious there may be issues as it relates to regulations and authorization for mitigation. But we asked the question, is the potential of collateral damage from physical kinetic solutions, whether it's the projectile in the counter drone solution itself, or the falling drone or debris, is that problematic enough that you want to avoid adoption of such a system? And again, it was quite striking, even more than jamming, where almost 60% either strongly agreed or somewhat agreed that a kinetic solution to mitigating the threat is not, at least not by itself, sufficient. It could be very problematic. So then we kind of summarized it all and said, do you believe that the risk or damage caused by counter-drone actions, mitigation actions, could be worse than the damage from the rogue drone itself? And this was really stunning. We saw 51% said possibly, 19% said yes. So 70% actually contemplated a situation where the counter UAS solution could be worse than the rogue drone itself. And that's kind of what's driving a lot of the discussion and debate around new counter-drone technologies and counter-drone solutions. And now, why is that happening? Well, we see here in this diagram, okay, detection. When you look at it from the detection side, of course, there have been some great technologies out there that have served their purpose extremely well as it relates to, for example, radar, optical, acoustic, directional finders. But in a sensitive environment, in an environment, an urban environment, for example, where you have a lot of high-rise buildings, or where you have birds, or where you have other issues, there are challenges. Radar, for example, can generate false positives. We know that. Optical solutions require a clear line of sight. Those aspects may not be readily available in an urban environment. Even more stark on the mitigation side, jamming and kinetic pose certain issues. You can have the signal disruption, the operational disruption that jamming can cause, the fact that jamming is only temporary, the operator can regain control of the drone, and then collateral damage that can be caused by kinetic, as we mentioned. So this is causing kind of a shift how people looked at counter UAS from the traditional military environment into today's sensitive and complex environments. The other aspect that we're seeing is a desire to capture the drone when possible, when feasible, when allowed, of course, for the intelligence benefits that you don't necessarily always, if you can avoid it, and if it's not necessary to have the hard kill, if there's a way to actually capture the drone rather than killing the drone or being unable to capture the drone, there might be some opportunities there from an intelligence point of view to learn much more about the rogue drones themselves, the pilot's locations, where it came from, and all the obvious intelligence that you can capture with the drone. Another issue, as drone applications become more pervasive, as a lot of friendly authorized drones affect each of these environments, there's a concern that counter-drone systems may have difficulties distinguishing between friendly authorized drones and hostile drones, rogue drones, if you will, and a very strong concern to avoid disabling or disrupting the authorized friendly drones in the environment. And you can see here that, are you concerned that your counter drone system or counter UAS system could possibly, or yes, disable or otherwise harm friendly drones? You see, that's a very big number, like 70, close to 78% were concerned about that. So that points to the implication of making sure counter UAS systems have that ability to distinguish between friend or foe and enable the continuity for the authorized drones that are out there. Finally, the most important question we said is, what kind of outcome do you want? What is the best possible outcome given all the different options that are out there? What would you like to be able to contend with as it relates to a threatening rogue drone incident? And this was quite remarkable. When presented with all of these different options, takeover of the drone was favored by a whopping 63%. Only 17% favored jamming, only close to 7.5% wanted a physical kinetic hard kill solution. And another 12%, interestingly enough, were in favor of another controlled outcome of sending what we call a fend off, sending the drone back to its original takeoff point in a controlled manner. So when you add those two together, you get to a 75%, 3/4 of the respondents wanting some kind of controlled solution as opposed to a jamming or hard kill solution. And that's that kind of points to this, our perspective here about a next generation approach for sensitive environments. And you can see on the detection side, of course, RF cyber takeover. RF cyber takeover delivers that fast and accurate detection without the false positives and without line of sight required. This is just RF cyber on the detection side. And then, of course, on mitigation side, the benefits are even magnified, where you can disconnect, take over, and take control of the drone, safe route, safe landing, and the benefit of total continuity, no disruption to communications, no collateral damage, no stoppages. The environment continues without that operational disruption. And that's kind of the paradigm shift, if you will, by new technologies that present these unique benefits that are really a necessity, really an imperative in sensitive and urban environments. And specifically as it relates to RF cyber takeover, a counter drone system that actually detects RF cyber signals, takes control of them, convinces the drone, if you will, that it has a new master, and then lands it safely, safe route, safe landing, safe outcome in a designated safe zone. What's important here to kind of define the RF cyber takeover technology is not only what it is, but what it's not. It's not based on jamming, it's not based on kinetic, and it's not requiring a line of sight. And another sort of very useful metaphor or framework, if you will, for looking at this is the incident life cycle. How this plays out when there's a rogue drone incident, how it's managed and how that differs between different technologies. So obviously you want to detect and alert, and then at that point on, locate and track, identify it, discover the pilot position, the takeoff point, identify, but then being able to have a controlled outcome, having an option, either a fend off, sending it back, or having it hover in place, or taking control and actually landing the drone. And you can see whether, the passive stages and the active stages. But this is another useful way is to look at the rogue drone incident life cycle and compare that to what happens, with a kinetic or jamming based solution with a very, very different outcome. The other aspect, though, that is important is the deployment, the use case, the physical execution of the counter drone solution, the ability to adapt and transfer very quickly. So we advocate being able to deploy the technology in multiple operational deployments. You can see here, of course, mobile, on the go military vehicle or civilian covert vehicle, and of course ground level tactical. And you need to be able to deploy the hardware, the antenna sets, as you can see here, for different situations. High altitude tactical, whether it be on top of buildings, on top of high topology mountains. Long range directional, relevant at airports, where you need the long range in the other dimension to cover landing strip airspace, things like that, and high altitude stationary as well, high altitude buildings on a more permanent basis. So you have to be able to look at the counter drone solution in the technology and how it can be deployed across multiple operational situations. And that kind of brings it all to the culmination of this operational disruption and continuity of point again. We asked the question, we asked the audience, when mitigating a rogue drone incident, how important is it to not just end the incident, but actually preserve continuity, actually maintain continuity, full function communications, transportation, commerce, everyday life? And a whopping 86% said, yes, continuity is extremely important. It's not enough just to end the incident, but you need to maintain continuity. That was 86% felt that was important. So in order to establish that continuity and maintain that continuity, though, it's not enough to deal with the counter drone threat of the existing drones on the market. You have to be sure that you'll be able to deal with the constant stream, the constant flow of new drones as it relates to drones coming from the leading manufacturers on the market. So you need a future-ready approach. You need continuous system updates. You need to be able to anticipate the unpredictable and rapidly respond to new drones as they come on the market. So it's very important that whatever the solution deployed, that you have these continuous system updates to deal with the new protocols and the new drones that rapidly come on the market on a continuous basis. In summary, all of this kind of can fit under the context of 4 key concepts that drive a 5th concept. Control, and you can see here a very important perspective of the best way to control the drone threat is to take control of the drone itself. You have safety, safe landing, safe airspace, safe outcome, not just ending the incident, but ending it safely for the whole environment, for all the actors that are there on the site. A focus, not chasing every single drone, but really focusing on the most dangerous drones that we mentioned earlier, those that have the heavy payload, the long distances. Focus on the real risk, the most dangerous drones, and employ in your system, make sure there's some sort of analysis, assessment, and prioritization. And then, as just mentioned, future. Not only dealing with the current threat, but always foreseeing the drone future, always staying a drone threat ahead. These 4 concepts, control, safety, focus, and future, are what underpins a drive towards continuity. Continuity, avoiding the operational disruption, having everyday life continue, and driving that continuity. And basically, RF cyber takeover is focused on continuity. Continuity being key to communications, transportation, commerce, everyday life. And with that, thank you very much for your time today. Again, feel free to continue the dialogue with me after the session. You have here my email again. You can connect with me on LinkedIn, and you can visit our website. Thank you very much, and thank you to IDGA, and thank you to all the survey participants, and look forward to hearing your questions and continuing this conversation. Thank you.
All right. Well, thank you so much, Jeffrey, for that great presentation there. And thank you again for joining us as well, Gabrielle. So great to have you both on. So I have a couple of questions. I think we have some time for a few here. So the first question I have is from Richard Stage, and he asks and notes that RF cyber takeover requires significant upfront engineering effort to re-engineer the drone, design, and test a solution. So how long do you believe it takes from the occurrence of a new threat to the fielding of a RF cyber takeover updated solution? Is this days, weeks, months, years? Where do you see that?
A great question, Gabrielle. You want to touch that based on our experience with some recent new releases?
Sure. Pleasure to meet everybody virtually. In terms of the system deployment in the various deployment environments or operational environments where our system is currently being used, the system in its tactical form can be taken out of its, Pelican carry cases, assembled in a matter of minutes. You can configure a mission plan in a matter of seconds, or you can upload a pre-configured mission plan that you've pre-configured in advance per different operational environment. And then the full drone incident lifecycle, as Jeffrey was mentioning throughout his presentation, it usually takes a matter of seconds. The system will detect a rogue drone the moment that it detects its RF. Once it's detected, we begin to extract the crucial information, display its location. We can classify the threat. You can determine if it's an authorized or unauthorized drone. Gain that crucial situational awareness of where the drone came from and its pilot's location, and then take control over the drone if necessary, or if the operator sees that that drone poses as a risk or as a threat. All of this can be done in a matter of seconds, really.
Gotcha. Great. So the next question that I have is, how do you decide which drones are the most dangerous, and what is the confidence level there?
I'll take this. I'll take this again. We have lots of researchers and R&D, market analysts. I always ask my nieces and nephews, what's the last bar mitzvah or bat mitzvah present that their friends are getting. But basically, we see what's out there in the market. It's very clear to see what drones are being flown throughout the urban environments, and we also use our network. We have hundreds of systems that are deployed, and we receive actionable intelligence from the field operators of what are the threats that they actually see in the different environments where our systems are deployed. Putting those two together is what enables us to focus on what the real threat is, as well as continually researching the market to see perhaps what the new emerging threats will be and already prepare for that in advance, really covering all our bases for a good hefty 90% of the market. But there's always always new things coming out, and we try to stay ahead of the game. But basically those are the two aspects that we rely on.
Absolutely. So the next question that I have concerns, how the D-Fend solution deals with RF silent drones in terms of detection and takeover. Can you speak to that a little bit?
Yeah, absolutely. So RF silent drones can be divided into two. One would be configure and forget. So the pilot would configure a flight plan, then shut off the RC and have the drone fly a pre-configured route. However, although if the drone is transmitting or emitting some type of RF, our system, as being an RF system, would be fully functionable and able to detect, track, classify, and take control over those threats. However, if the drone is not emitting any RF whatsoever, then us as an RF system, we would be blind to that, and that prompts us with developing with our customers our multi-layered solution approach. Whereas if we can provide, near hermetic solution for almost all drones or all threats, say someone wants to really use one of these silent drones and send them on a blind kamikaze mission, which we're seeing evidently is not so it's not used too often because the operator still wants to have some type of connectivity or validation that the mission is being conducted, and not just sending it out and praying that the drone is going to conduct its mission. But however, it does exist, and to that we apply the multi-layered solution approach, whereas RF cyber would be the core to provide the near hermetic solution, and we rely on the traditional technologies such as radar or optics for the detection aspects, and perhaps traditional mitigation technologies that can mitigate the silent non-RF emitting drone.
Gotcha. Great. Well, I think we're running a bit short on time, so I think we're going to have to cut the Q&A, but just want to really extend my thanks to Jeffrey Starr for that great presentation, and to Gabrielle Benheim for those great answers and insights to our questions as well. Really want to thank you, gents, for coming on.
Thank you
for having us. Appreciate it.